name. If it exists, we're just going to return this value because it's going to be cached. And if it doesn't exist, then we need to create it. So we're going to create a new authorization policy builder, call the add requirements method, and introduce a new permission requirement specifying the policy name, which, as I said, is going to contain the actual permission name. Then we're going to build this authorization policy, and we're going to add this policy to the authorization options instance. This is important so that we can cache the permission policy for the specified policy name. And the next time that this policy is requested is going to be returned by the base call to get policy async, and we won't need to create the permission from scratch. At this point, we need to make a small detour into the application layer and also define an authorization folder. I will add two simple types into this folder. One is going to be a permission response containing the user's identifier and a hash set containing the user's permissions. And we're going to use this as a result of the getUserPermissions method on the iPermissionService abstraction. And the reason I'm doing this is so that we can have a generic abstraction for obtaining the user's permission in our application. Inside of our modular monolith, we will place the implementation of this service in the users module. But in the future, when we extract some of the modules outside of the monolith and we move into a microservices system, each extracted module will have to provide an implementation of the iPermissionService. And this is how we are going to enable authorization in a distributed environment. You're going to see an example of this in one of the next chapters, where we are going to extract one of the modules into a separate service, and we will have to solve authentication and authorization in a microservices environment. For now, just remember that this is a simple abstraction to obtain the user's permissions based on the provided identity ID, and is going to be implemented in the users module. We're going to add the implementation in just a moment, but I want to show you where this is actually used. So I will head over to the custom claims transformation, and if you recall from our diagram at the start of this lesson, this is the step that we apply before we authorize the current user. It implements the iClaims transformation interface, which allows us to modify the claims principal before any authorization policies are applied. I'm going to need a service scope factory injected into my custom claims transformation so that I can create a custom scope and resolve the permission service. And now you can start to see why we need this service. We can get the identity ID of the authenticated user from the getIdentity method, which is the helper method that I showed you earlier. And then we can call the getUserPermissions method from the permission service, passing in the identity ID and getting back a result containing the permissions response. If this is a failure result, then the current user probably doesn't exist, or we ran into some other problem, and we're going to throw an evently exception and specify the result error. We're throwing an exception because we don't know how to recover from this failure. Otherwise, if this request succeeds, and most of the time it will, we're going to create a new claims identity and introduce some custom claims. The first custom claim is going to be the subject, which is going to contain the user ID that we get from the permission response. Then we're going to loop through the permissions that we also get as part of the response and introduce them using the permission claim into the claims identity. Then I'm going to modify the existing claims principal and call the addIdentity method and introduce the custom claims identity that we created, which is going to contain the subclaim as well as one or many permission claims. How all of these components fit together is in the authorization extensions class that is just going to configure them with dependency injection. I'm adding the custom claims transformation as a transient service, as well as the permission authorization handler as an iAuthorizationHandler handler implementation, and the permission authorization policy provider as an iAuthorizationPolicy policy provider implementation. Of course, we will need to call the addAuthorizationInternal method from the infrastructure configuration type, and we can do this after the call to addAuthenticationInternal. So let's say addAuthorizationInternal, and this is going to wire up all of the components required for permission authorization. Now let's go ahead and implement the iPermissionService in the users module. So I will close all of these types down because we won't need them anymore, and let's move over into the users module. I'm going to start from the application layer and introduce a new use case in the users folder. This is going to be the getUserPermissions use case, and this is actually just a query accepting an identity ID and returning the permission response that we defined in the common application project. The handler for this query is going to select the user ID and the permissions of the user from the database, and is going to query the users, the user roles, and the role permissions table, join between them, and return a collection containing the permissions for the current user. Now we can move into the infrastructure project, where we are actually going to implement our permission service. And I'm going to add that implementation under the authorization folder. And the permission service could not be simpler. We are just injecting the iSender from Mediator and sending a new getUserPermissions query. This is going to be handled and return back a result containing a permission response, and then we can assign the user's identifier and the permissions as custom claims. We also need to register this with dependency injection, so let's add it in the users module class, and I will say add scoped iPermissionService and then permission service as the internal implementation. And this is how we can implement some generic components inside of our modular monolith by defining the abstractions in the common folder and then providing the implementation in the appropriate module. Now notice that our permission authorization is going to work for all of our modules because the custom claims transformation is going to resolve the permission service that is implemented in the users module, regardless of if we are querying an endpoint that belongs to the ticketing, the events, or the attendance module. If we close this down, let's go to the get user endpoint, and I will go to the presentation project and find the get user profile endpoint, and we can make a few adjustments here. First of all, I'm going to get rid of the ID from the route and the ID argument, and I'm going to replace this with a claims principal, and let's call this argument the claims. I'm going to add a using statement, and the reason I'm doing this is because I want to implicitly get the identifier of the current user from the claims principal. You can inject claims principal as any other service, and what I'm going to do here is say claims and then get user ID, which is the helper method that we defined in our common project. And now I can specify a permission in the call to require authorization. If you recall, this accepts a name of a policy, so I can say something like users read, which is the actual value of my get user permission in my domain layer. Ideally, you will define this inside of a set of constants, and this is something I'm going to introduce behind the scenes, but for now, let's just hardcode this value and test our permission authorization implementation. I already obtained a valid access token, and you can see that the route to fetch the user's profile is now simplified to just users/profile. So let's send this request to our application, and we are first going to land on the breakpoint inside of the custom claims transformation type. This is where we are going to resolve the permission service from dependency injection, and you can see that we get the implementation from the users module. Then we're going to grab the identity ID, which is the user identifier in Keycloak. After calling the permission service to fetch the user's permission, you can see that we get back a success result containing the user identifier and the collection of the permissions assigned to the user. Finally, we're going to create a new claims identity, add the subclaim, and in the list of permissions, you can see that the current user has 17 permissions. So I'm going to hit continue as we add the permissions one by one, and we land in the handle requirement async method. If we take a look at the requirement, you can see that the value is users read, which is the same value that I set in my get user profile endpoint. If we go back to the authorization handler, we can get the user's permissions as a hash set from the user's claims, and this contains all of the permissions for the current user. Of course, we are going to succeed in our authorization requirement, and if I hit continue, we land in the endpoint where we are going to send the get user query to fetch the information for the current user. So if I hit continue, we will get a response back in Postman containing the user's information, and we can conclude that our role-based access control implementation is functioning as intended. One last remark I want to make as we wrap up this lesson will be about the permission service. The custom claims transformation, and by extension the permission service, is going to be called on every API request, which means that we will be hitting the database every time to fetch the user's permissions. This is potentially an expensive operation, and moreover, it will be unnecessary to query the permissions every time, so it would be a very good idea to cache the response of the permission service for at least a short amount of time, for example, a few minutes. I don't want to implement caching for the permission service just yet, as I want to show you a few more things in the upcoming lessons, but I am bringing this to your attention as I think it is very important. In this lesson, we implemented role-based access control using roles and permissions defined inside of our users module. This gives us very fine-grained control over our API endpoint. And with this lesson, we are also concluding the authentication and authorization chapter, in which we introduced Keycloak as an external identity provider, I showed you how to authenticate with Keycloak, how to register a user with Keycloak, and how to implement role-based access control using permissions. In the next chapter, we are going to discuss a very important topic when it comes to modular monoliths: architecture enforcement.